Welcome back. Looks like the microphone's working. Okay, so we polished up the engineering change order database. We brought the standard for the mini-PCBs up to acceptable for initial release. We made that little interface device board, mini-PCB, 00A-010. The initial revision A had issues that I should have identified before ordering. It works, but immediately when I got it, I was like, oh no, mistake, could have been better, mistake. So I quickly respun the board and ordered Rev B. That should get here in a couple days, maybe a week, not quite a week. And I showed y'all kind of the concept that we're going for with these obsolete mini PCBs that are single transistor amplifiers. And then we wrote some code to automatically insert the images that we export from Eagle into the datasheet. So that'll save us some time. So I think we're almost ready. I think we're basically ready for me to start doing mini PCBs the right way, according to the spec, the standard. And just to remind us all, so I have the standard here. So design standard, this was from 20 August. So yes, this has got the stuff, the bare minimum of stuff to just start cranking them out. So we got a board identifying number, a part identifying number, and I decided to put X. So these X's are placeholders for the part number, but I will actually put the letter X at the very beginning during the prototyping process, and that way I can feel free to spin the revision letter during the prototyping process as many times as I need to get it perfect. And then when I finally have something that is perfect and acceptable for release, then I will remove the X and I will set the revision letter to A. So it'll actually be a different part number. So this guy right here would be, if I did it today, this would be a prototype, and it would have an X in front of the part number. But since I wasn't doing that, this used the part number as if it was released, and now when I actually release it, it's going to be Rev B. So, I'm that you don't see that here, but I already have that in my head. I'm gonna when I'm prototyping, I'm gonna have an X in front. So what that means is the first time when I initially release the board, the pieces that people buy, like I'll have prototypes that are what the final design is. The only thing that's different is the X in front of the part number. So maybe we could make that a collectible thing where, hey, Nolan only made 10 of these boards, and then he broke one of them up and soldered it, and he broke another one for showing people in the video, and then he gave one to his friend so and so, and he gave another to so and so. So that's 4 of them, and I bought one, and you could have yours that you bought off eBay. Maybe I maybe I make it like $5 more expensive, and of course it'd be labeled really like prototype version of that particular mini PCB. And then if you watch the video and you go, oh my God, like, oh wow, I really like that circuit, I'd like to prototype that circuit, then you go on eBay, and if you're early enough, which means probably like within the first 5 years of me releasing it, if you're early enough, there will probably be a prototype one left. But yeah. And then I think I'll price it so that if I just sold all the prototypes and I never did it again, I think I'll price it where, well, anyways, I don't know if I want to talk about money and kind of ruin the vibe, but I'm going to price it in a way where it's like break even for me. So if I just sell that initial batch, like this whole hobby, you know, in the workshop in my backyard, wasn't a negative. So it just was a net zero. And then if a professor or teacher calls me and says, hey, I want to do something like this in my class, right? Whether it be a magnet high school engineering class, or like a university lab or university circuits class. And I say, oh, cool, wow, well, let's, when do you need them? How many do you need, right? First semester, okay, cool. What circuits are you interested in? Help them pick through. Okay, well, let's do a single transistor amplifier. Probably give you 3 different types and let students pick, so you have a little bit of diversity between the projects. And then, or you could like have, anyways. So yeah, I could work it out with you guys. But yeah, I think so. Anyways, so we'll have an X when we prototype, and the last batch that we test, we'll have X on the part numbers, and then I'll sell those for a little bit higher. So that's what we're thinking there. So we got the part identifying number, and then our categories, right? So I probably should have just scrolled down. But so anyways, so the part identifying number, and then so these are our macro categories, right? So test boards. So the guy that we made together, that's a test board 00A. And then components and sensors, actuators, amplifiers, filters, oscillators, radio circuit, RF, signal converters, power, digital, computing, and this can change. Like I added computing earlier last month. I added it in August, so I hadn't had that on there before. But I was like, no, yeah, because I want to do like some analog computer circuits. And then I thought, well, you know, I could also do a larger board and put like a super simple Turing machine or something like that. So I don't know, we'll see. Worthless stuff, really. Okay, so yeah, so these are the categories. I think we're going to start in 04A because amplifiers are easy to understand, right? Small input, big output. So they're easy to understand. They're relatively simple in terms of number of components. Like they're not simple to just understand. It takes a little bit, so don't feel bad if you don't understand it the first time you look at it. But as far as like electronics go, there's not a lot of parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Like there's not a lot of parts. So anyways, yeah, so we're going to start in the amplifiers, and then in the amplifier group, right? So I got categories and subcategories. So in the amplifiers group, I've currently got 3 subcategories: operational amplifiers, transistor amplifiers, and application-specific amplifiers. Now, operational amplifiers, that means op amps. So op amps are a component where it's a little it's a small little chip, right? And inside that chip are a bunch of transistors, and those transistors all form an amplifier. And it's a very good amplifier. Pretty much any op amp that you can find is going to be a pretty good amplifier. Now, compared to other op amps, it may be the worst op amp in the world, but compared to amplifiers, it's going to be a good amplifier. So like these guys, these single transistor amplifiers, they're okay, but you're not going to be able to achieve the same type of performance, repeatability, and size, form factor that you can with a simple op amp. So anyway, so A is going to be op amps because that's most relevant. B is going to be transistor amplifiers because that's what's inside the op amps. So you may hear me say, all right, this is obsolete, guys. Like, you really don't need to, you can't buy this, learn this, and go get a job using this. Like, this is obsolete from that perspective. Nobody is paying for rent. Nobody is paying for their truck. Nobody is paying for food based off of these little circuits that I'm going to put on these boards. You have to take these little circuits on these 04B boards. You have to take these circuits and use them in something a lot bigger. So, and most people don't know it. So, whatever. Okay. All right. So, op amps, transistor amplifiers, application specific. So, application specific, we can have some current sensing. We can have some instrumentation amplifiers. We could do like a EKG analog front end. We could do an ultrasound analog front end. We could do a difference amplifier, like for kind of feedback and just kind of interesting, applications. We could do just a whole bunch of amplifiers that you'll like. Hey, electrical engineers have put a couple decades worth of work into this particular application, and here's the lessons they learned, and then some company paid a couple salaries, right, to a bunch of engineers to design a chip that does that application really, really well, and then they sell that chip for $1.50 in volumes of thousands. So we'll look at some of those chips and do boards that are actually like, you'll have a mini PCB in 04C that is specific to a certain chip. So basically, it's a demo board. So yeah, so that's kind of the plan. This will be generic op amp amplifiers. This will be generic transistor amplifiers, single transistor, multi-transistor, and this will be application specific, which is kind of code word for demo boards. Yeah. All right. So I think that's where we're up to. Of course, this is what the panel for that will look like. This is the panel for that size. This is what the panel for that size looks like. Yeah, this is probably the one we're going to use the most, right? Because it's large enough to fit. It's like maximum area without going below 9. Like, you get 9 pieces per panel. So if you go, so you get only 2 this direction, 2 that direction, you only get 4. It's like, less than half. So yeah, less than half. Wow. Yeah, because 4.5 is half. So anyways, but if we need to have the extra space, we'll have the extra space. And this is the interface device board, which this changed. I should update this picture. Yeah. Well, you know, we got to get back in here and update the standard. So, okay. So that's the standard. And the product catalog that I've got, this shows stuff that I did last year, so about a year ago, September, October, November of last year. And we're going to tear it all up and redo it. We're going to reassign all these numbers to new boards. So each of these boards, I'm going to go to what I had. I'm going to take that, I'm going to tweak it to the new standard, and then give it a new number. And then I think by the time I got down to here, I was like, oh no, I should have done a bunch more of these circuits. So I kind of packed it all too tight, so I couldn't really add a bunch of similar stuff to it in the near vicinity. I'd have to like go grab a whole new number section. So anyways, so let's see. Okay. How do I want to do this? Let's duplicate, move or copy, create a copy before sheet 0. Yeah, that's fine. And then I'm going to say old legacy maybe would be better, but that's fine. Oh, yeah, that one's old. Okay, this one we're going to tear up. Okay, so here, yeah, so good enough. Okay. All right. And then what we have here is not that. Here. Okay. And I want to find, well, it's just there, the part number thing. And then I want to go down to the section that has this right here. So 0 is where it starts. So I can have 0, 0, 0. That's an interesting one. Should I make a 0, 0, 0? That's what the number says. 04B-000. Revision A. Package. Now this is going to be THD 1206 0805 0402. Uh, 0402, and then reserved. And then I need to put the this came from this putting the single quote there. Didn't that come from the guy that invented the spreadsheet? Wasn't that something that that he came up with? I'm pretty sure that was. I could be wrong, but that should be 200. So then I come here and I do this and I hit that. Will it go all the way down? Not quite. Close, though. Wonder why it stopped at 104. Okay, that should be, yep. I guess I could keep going, right? Why did I say, somewhere I said this would only hold 200. I have no idea why I said that. Because 99, then that increments. It hold 1,000. Well, 1,000 divided by 5. Oh, that's why. 1,005 is 200. 200 unique circuits. Okay, yeah, I know how to do math. All right. All right, so they're all going to start Rev A. Actually, I should say X. That's it. X, because they're all developmental at this point. They're all ideas. So since it's never been released, it's an X. Or we don't have a current revision that's approved for release. Therefore, X. No. Release. There you go. Released revision. That's I don't know. Current rev. I don't know. Current rev. I don't know. But it'll be X for initial for an idea. It'll be an X. And then now that we've got this, I can just say filter for that. And then now I'm looking at just the through-hole device. And then you can see, okay, well, this is my, we'll do the through-hole first before we do surface mounts. This is my space for that I want to start in. And this is how many? This is 40. That's not nearly enough. We're going to stretch this out. We're going to keep going. What? Okay, it's shift that way, and then page up. No, it's control shift. Yeah, control shift, and then like that. Okay, cool. All right, so we'll copy. We'll come down to the bottom here, and we'll paste. And then that messed up my really. This might overflow it, but you know, we'll give this a try. Okay. Okay, right here is where it breaks my part number system. So backspace. All right, cool. This is the full part number space for the 04B category. Now, if you think you're a trooper and gonna watch every single video that I make, doing all the work to flesh out this one group, and then you look at all these groups and you think that you're gonna, be a trooper and watch every single video for every board in every group, first of all, you're almost as crazy as I am, because I think I'm gonna do that. That's just crazy. But why not, right? I mean, I'm in my 30s, so I got another 50 years maybe? Nah, I don't got 50, but And what else am I doing? I might as well make a repository of essentially a full stack of educational material for electronic circuits, all the way from the theory and the circuit to the CAD tools, schematic capture, library management, the engineering procedures that are needed to organize the activity, the documents that are needed. Oh yeah, speaking of, I'm down in that corner. See, I can't see the bottom, but yeah, those numbers, they get like that. They get up there to what? Oh yeah, this is I filtered for THD. So when I select them all, then you'll see them all. So it goes up to 999, and yeah. So anyway, so this is the full space, and then since the same circuit will be on those 4 consecutive part numbers, I can just filter by THD and then start putting in my circuit ideas. So I know I want to have a good chunk of single transistor amplifiers and then a good chunk of multiple transistor amplifiers. So let's divvy it up. Probably going to be more single. No, should I make it half and half? Tell you what, we're going to do that 66.7, 666%, because that's like related to E or something like that. We're going to make the bulk of it single transistor amplifiers. So we're going to go down to 665, this guy, and description 2 is going to be, description 2 is going to be multi transistor. Proper caps or lower cap? No, just multi-transistor. Everything here is an amplifier. And then we'll just take that guy all the way. Oh, I should unfilter right now. Select all. Yeah. Well, I don't have to, but like that. Oh no. Here, we'll do this. No, don't tell me. Here, we'll go down to, come on, really? Okay. Delete. Now we'll go back up. We'll take this, we'll hit that, and it should go all the way down now. Okay, cool. And then up here, we'll type, we'll go to the top, single transistor. Is this the right approach? Maybe it's the other way. Maybe it's the first 333 get single transistor. Yeah, we'll do the first. Well, 333 divided by 5. Well, it goes to there. No, not there. That's 33 is that one. So we'll put, clear those guys. Whoops. Here, I can maximize that. Multi-transistor, okay. Let's see. Then I have N-type and P-type. I was a year ago putting that distinction. So if you were interested in the N-type circuit or the P-type circuit, and you just do it that way. And then I was designating if I had a potentiometer on. Yeah, I think I should probably do the N and the P again. And the trim pot, I'm not so sure about. So I'm gonna go ahead and just set it on THD. Work with a smaller list, and then so I got 200 of these. The first 330 are single transistor. So the first 150 can be N-type, and then the second 150 can be the exact same P-type, N-type. Then P-type. This just goes down to the last single transistor one. And okay, right there. Cool. Multi-transistor. What was I? How was I? Was still doing N-type and P-type, but you could do mixed, so like mixed N or P. Like the push-pull is mixed, so you're not going to get some circuits unless they're mixed. So you won't get any of those until you're up in the 300 numbers. It's fine. But some multis will just be N's and some will just be P's. Yeah, I don't know. Seems like 37, 31. Huh. I'm that bad, huh? So that'd be 36, 32, 35, 33, 34, 34. Is that for real? Do I know how to do math? So 34, 34. Well, I know how to do math. I don't even know if I want them to be an even split though. Okay. So let's see. So I'm going to put the name like common emitter. Yep. Common emitter, emitter follower, common base. So I'm going to have that name here. Then single, N type, right? And then the number of resistors and whether it's got a pot. Yeah, that's probably good, but I don't really have I don't really have 5 columns. I have some VBA code that when I click the button over here on the overview sheet, it runs through all the sheets, and well, wonder if that will cause an issue, but you just watch. So I click update and it runs through, and it skipped my sheet, didn't it? Well, no, well, you would. Why is idea only 75? If it should have ran through that sheet. I thought it pulled it off of oh, it pulls it off description 1 key. Yeah, okay. All right, that makes sense. All right, so if I don't put anything in the key, it doesn't count it. That's right. Yeah. Okay, so yeah, that's why those didn't show up. Now, let's see. So common emitter, emitter follower, common base, cascode. Trim pot. I don't know what I want in for. I do want to have if it has a trim pot though. Okay, so we're gonna do okay, so let's pick it. How many trim pots do we want? A lot, mostly trim pots. So so probably for every circuit we want a version with a trim pot and a version without. Some we don't even need them with, right? So let's do the first. No. That's it. Everybody has a trim pot, right? So let's default to having it, and then we can remove it. Yeah, so let's default to having a trim pot because it'll give students the something they can touch, right? It's easy to touch, so they could touch it. Okay, so most of the stuff will have trim pots on, and then common emitter, emitter follower, common emitter, emitter follower, common base. Yeah. So we only have 3 types. So we probably should divide these up evenly. So if we have 333, that means we get 11. Yeah, hang on. Let's go to, if we have 34, 34 divided by 3 is 11. And then So we're going to skip. We're going to skip the 0 to 5 section, and we'll just skip it arbitrarily, and we'll just start here. This will be common emitter. Sorry, my brain's still firing up. So common emitter, and we get to have 11 of them. So 14 minus 2 is 12, minus 1, that should be 11. 11, okay. And then common base. (16 minus 5), A. Delete. Okay, and then they don't call it common collector, they call it emitter follower. But that's what it is. It's a common collector. So the transistor has 3 pins: emitter, base, collector, emitter, base, collector, base, emitter. And you can basically, the way that you use a transistor to amplify is you hold one of the pins constant. You wiggle one of the other pins, and then the other pin will wiggle more, but in phase with the pin that you're wiggling. And since it's wiggling more, it's amplified. Yeah. And so common emitter is the emitter is held constant, and the base is wiggled a little, and then the collector swings a lot. And then the common base is where the base is held constant, and the emitter is wiggled, and the collector has the signal out. And then the emitter follower is where the collector is held constant, the base is wiggled, and the output signal that's larger than the input signal is on the emitter. Yeah, so there you go. You got 3 basic type of single transistor amplifiers. And we're just going to do 33 circuits, which is not that many, really. So I kind of have to pick them carefully, or I fill up my space with junk, and then nobody's going to use it because it's junk, right? If they're not carefully picked. Okay. Okay, all right. And this is for N-type, and then we go down to the P-type. We'll just have a P-type version for each. That's yeah. Select all. Copy. Paste. There we go. Why did that not go all the way down? So common emitter, I got 11. Oh, it's because there was an odd number. Okay. So 335. (11, 335 is going to be something special. I don't know what yet. Maybe multi, maybe single. Okay, so currently we have mapped out 66 mini PCBs. They will all be single transistor amplifiers. Half of them will be N-type, half of them will be P-type. They will be, these are unique circuits. Each of these circuits will have 4 layouts, or there'll be 4 boards of each one, right? Here, let me drag this down. Oh, not that far. Right here. Wow, it glitches so fast. Okay. Here. Yeah. Control Shift, arrow up. Copy. Tab to the bottom. And we're going to hit paste. Paste. What's going on here? So I have common emitter, common base, emitter follower. It should end here, right? What's this doing? Y'all like watching me? Now you know why I struggle so much. Because I got issues, but you got them too. Okay, 55. That's the correct number. Then my paste should start here. So if I copy this and I go down and I find that stuff and I paste here, then I find the bottom of this and I delete this. Yes, that's correct. That's what it's supposed to look like. Now I can copy this, come here, and go up to where it switches to N-type, select this, and hit paste. And I can say copy here. Oh, it's going to take forever. Just go up to the top and paste there. Okay, except the first 5 we're going to leave empty. Mystery circuit, we don't know yet. Okay. This is a mystery circuit, we don't know yet. All right. THD to reserved. Okay. So let's see. So the through one will always have a trim pot. Is that what I'm going for, Nolan? Through hole trim pot? It sounds about right, because if someone's using through hole components, they're not going to be super experienced. Or if someone's using through hole components and they don't want a trim pot, then they should have enough experience to just use one of the surface mounts, which would be a smaller layout, so it should have a potentially better performance. I guess, I assume, I don't know. We'll see. We'll never know with the analog discovery, but maybe Keysight will do another one of their competitions, and maybe someone can point them to my channel, and then they'll be like, hey, let's send some tools and equipment to that guy, and he'll put it right there on his workbench, and then he can just up his the quality of his videos, and yeah, it'd be great. Okay. It's 9 p.m. on a Thursday. I guess I'm allowed to be a little bit slow. Okay. Plus, y'all are probably y'all are probably at work in a cubicle somewhere, and you put your headphones on, and you're like, I'm gonna listen to Nolan talk while I program something, or while I design a layout. He's good white noise. We can just have that playing in the background. So, anyways, so I'm not trying to be super entertaining, but I am trying to be acceptable for playing at work. Okay. Okay. Yeah. One of the things when I did these prototypes a year ago was, as soon as I had it all soldered, as soon as I soldered up a couple of them, I was like, I want to add a little cap there to see how much it affects this particular one when I can just swap, unswap, if it's even noticeable, right? So I thought, well, I don't necessarily want to put it on the board, but I want to have one that has that cap as a permanent component. So I want a little bit of variation on each of these. So if I only have 11 that I can pick from, that really means 4 or 5, and then a couple flavors, right? Like different feedback, capacitive, filter, different like slight tweaks to it. So it's really only 5 circuits. Are we ready to get into Eagle and start planning the circuits? So run as administrator. Yeah. Okay. Let's see here. Well, let me turn that guy off. All right, cool. Then 00B, 04, 04B. And these are all getting torn up and renumbered. So a little bit traumatic here, but in case you're curious, let's step through this. So this is from a year ago, almost a year ago. And since then, I've changed the title block That's snapped that to the frame. I still like. I changed a little bit. This I gave myself a couple more options on the schematic frame here, but I still like that. I still like the way that the components are, the symbols are. I toyed with putting the part number here, decided not to. So yeah. So let's how am I gonna organize my file directory here? I'm gonna copy these all to a folder called Legacy. So open project, new folder, Legacy 2021, and then all of the, I can't select them all, huh? What I can do, I'm going to close Eagle because this is going to be traumatic to the file structure. So we're going to close that. We're going to go to that section of the computer, 00A, and we're going to grab all, oh no, not 00, 04B. We're going to go to this section here. We're going to grab all of them. We're going to drag them into Legacy 2021. Okay. All right, cool. So we got all that stuff there. Now we'll go back into Eagle. This old version of Eagle, if you don't run it as the administrator, if you try to modify one of the libraries, the changes won't stick. It'll look like it's saving, but it's not saving it, and then it'll throw away all your changes. Not sure if that happens when the library is outside of the installation path, but yeah. Okay. Whatever. Y'all get what I mean. Okay, so this guy, no potentiometer. So basically, what I just said was if it doesn't have hot, it's not going to be a board. Essentially, that's what I just said, right? So trim pot, I don't have it until I get down to here. So 008. By the way, this is what I showed y'all the other day. So it was this circuit. Right, there it is. Cool. So we're going to close that. I'll just open it for fun. Close that. I wonder if I can. Can I copy the project? Just copy. Just put it up here. And then 04B 005. there it is. It copied it too, right? So if I go back down here, 8 is here, and it's unchanged. It's exactly, should be exactly the same. Excellent. So I'm not going to be modifying that. That will be the way it is. And now I can take this guy and I can start ripping it up. So first of all, this guy gets renamed to 005. That's correct, right? Go back to here. 005 is correct. And what you're going to see is this circuit. That's going to be the circuit. Go down to here. What was I doing on this guy? I was using that one, right? So this got to be the same component. And we'll see what we got here. Okay. Can't close that. Close that. Go back to here. Rename. Well, this I could delete. Delete. Yeah, that. Delete. This I want to rename. 005. Five. Rename 5. 555. Okay, cool. And then in this guy, I don't have, this is not what I'm supposed to do at this point in the project, but it's not going to hurt, so. Okay, save. Okay, save. Close. Let's go into the schematic. All right, so first things first. If I say library, update all, couldn't do it, something reasons, right? So we're going to delete all that. We're going to go to the schematic. Schematic. Say OK. Set it in. Bam. All right, cool. So this is the new updated head, right? Like letterhead. Let's see. Invoke. So I got this guy. Invoke. I got this guy. But I thought I had a. So if I say miniPCB, it's a 5-pin, 33 millimeter. Yeah, I have a whole bunch of options. Why is it not one of those? Cancel. This is a miniPCB 5-pin. Cancel. Well, that must be an old, I don't know. It's supposed to have all these options up here, but it doesn't, so. Yes. Okay. All right, there we go. It forced it to update, so now I don't have to do any of that. All right, cool. So, yeah, so this stuff here moves to the power section. And then the whole thing, grab it, and then I'm going to put it, I think I'll put it over here like this. So, there. I think so. Move group. That. Move group. Was putting it one click off? Probably not. Yeah, not. It's putting it straight on because that's one click. Okay, cool. Let's see. So, yeah, that should all be fine. Do I want to pull that Q1 further down? So if I right click, say invoke, I only put one gate on that guy. Now I was working on components, so I don't know if I have them in this library, but drawings, transistor. Okay. So I didn't use this one, right? I didn't use this one. These are our surface mounts. I did not use this one. Did not use this one. Did not use this one. Don't need that. That's not what we show. That's not what we show. That's not what we show. NPN. Why does it say the footprint is SOT23? Okay, well that's a mistake, but this is probably what I want to put here. Where do I want to put this though? So this is enough room for one, and it's probably going to be a lot of wasted space for most of the schematics that we do. So I can hide it, lock it on the side, or I can kind of center it. I can put that down there. Note, pronounce vary per that. Okay, I need to go back in and make that all upper caps though. None of this proper cap stuff. Work kind of drilled that into me this past year, so I need to go in there and update all that. NPN bipolar junction transistor, that all needs to be uppercase. That's TO92. So that's wrong. So control panel, libraries, miniPCB, symbols. So I got drawings, TO92 NPN. That's that one. And this is not. This says SOT23. That's not. It's TO92. Transistor outline 92. Example part 2N394. Schematic symbol. Collector. Oof. Might have to face emitter. Well, doing away with the value. Not going to have the value. But I should probably leave the name where it is just in case. No, I'll put the value back on just because if someone wants to know, hey, well, where would the value go? Well, kind of go in that vicinity right there. And then part, and then bipolar, junction, transistor. And then emitter, base, collector. Do I need to put that? No, I'm not going to put that. We're all adults here. You can figure it out. I think I want to make the text here smaller though. Size. Let's bump down to millimeters. It doesn't need to change. Size. 1.5. Is that too small? No. We'll try that. Save. Then we can go back to our schematic, library, update all. This should, there it is. Okay, so that is now up to date. We can drag that down to there. It's weird. It's pretty weird. It's a weird thing to put in a schematic, but if I put it over here, then my wider, because I've got invoke. Now it's got all the other ones, but like this guy, right? It's wider. So if I put the pinouts on the side, then I won't be able to use my wider frames. I've already got this title block kind of making this a dead space. So I think we'll try this, and then if we don't like it, we can always change it. But yeah, so what's going on here is the footprint that goes on the board. So this guy right here, pin 1 is this guy. Pin 2 is the one in the middle. And pin 3 is this guy. And pin 1 for the transistor that goes right here in this circuit, pin 1 needs to be the emitter. And pin 2 needs to be the base. And pin 3 needs to be the collector. Now, the number doesn't matter. What matters is emitter needs to be on this pin, and the base needs to be on this pin, and the collector needs to be on this pin. So while I say 1, 2, 3, and a lot of people in industry number their TO92 transistors like this, 1, 2, 3, some people may go the opposite direction, 1, 2, 3, the other way. And then some people may be random for unknown reasons. So you can't say 1 is always the emitter for this because your numbering could change. So you really have to just be careful and look at emitter is this pin right here. So this is the emitter, this is the base, and this is the collector for this particular part right here that I've put in my library. And I don't have multiple versions in my library. I don't think I do. I think I just have this guy. And then I'm not going to do, I decided against doing a different layout as if this was a MOSFET. So here in the schematic for 04B 005, you're going to see an NPN symbol, but you could use an N MOSFET. You just have to make sure that the gate is here. The if it's in MOSFET, the source is like the emitter, so the source is here, and the collector is the drain. So so it would go source, gate, drain. Yeah. And then you'd have a different symbol. So this would be for your enhancement mode, right? Source, gate, drain. Source, gate, drain, what I just said, right? And this is depletion mode. So enhancement mode, the body diode, right? And depletion mode, it biases a little differently. I forget exactly. It's been a couple of years. No, Nolan just doesn't really know because he never really learned it. What? I learned it. I paid attention in school. I was awake. I attended class. Okay, fine. I didn't really learn it. And I forgot when I read it online. So you have ground, positive DC, negative DC. We're not using the negative DC, so I put an X, which I just created a component that I call NC for no connection. And I just set that. It doesn't have any significance. Like in Altium, they have a no ERC, and it's a little X, and basically it prevents the ERC rules from applying to that net or pin, right? Okay, so this is supposed to be the very first mini PCB. Do I want to start with this guy because it's a little more complicated than the other one? I think I do, because that way this guy, the one that I demoed first, is the first official mini PCB done to the standard. Nice. Nice. Okay. All right. All right. So let's so that should be, this should be good. There wasn't anything about the particular circuit that I wanted to change. So now that we got that, let's go here and let's circuit category. Transistor amplifiers. Circuit name. This is a common emitter amplifier. Circuit variant. This is 1, 2, 3, 4, 5 resistors, 1 trim pot. So 5 resistors, 1 trimmer. I'm just going to call it trimmer, but it's a potentiometer. 1 trimmer, drafted by NM. We're going to put 01 September 2022. Wow, 2020 does not feel like that long ago, does it? 2022. And we're not going to put any of the engineers in QA right now. Rev A, we're not going to do that. Oh my goodness, we need to go grab an ECO number. Ooh, so exciting. We get to go grab an ECO number. Title. Title is, what did I have previously as a title? Don't send an email to sales. It's not set up. Oh, this is old. This is 2020. You want to see what I was up to in 2020? I was trying to make it work, right? So I had a cover sheet. I had a continued sheet, right? The cover sheet had a little revision block up there. The second sheet, I had a block diagram of the amplifier showing input, ground, output, and then like just a rectangle showing the connector to the board, right? So the 5 pins right here. This is how what I was doing in 2020 to try and figure this all out. And I wasn't quite sure. This may have been more than 5 pins. Did I have multiple ways? Yeah, so I was trying to do with a negative supply. Yeah. No. And I have a death cross. 2020 is June of 2020. Yeah. Oh well. We learn, right? So that's not what I was looking for. This is not what I was looking for either. Okay. What was I looking for? The title. Yeah. What do I want the title to be? Not able to find a good example from the other one. Common emitter amplifier. Don't want it to be single transistor amplifier. Transistor amplifiers. Single transistor. No, it goes the other way. Yeah, it goes the other way for sure. Okay. So this cut becomes single transistor circuit. Yeah, and then common emitter amplifier. Okay. Bias trimmer. Okay, so basically your input. So the way my schematic, I've enjoyed drawing my schematics recently is I put a dashed line. I put a label up at the top called inputs or outputs or power, and then on that line I will set a pin, right? And that pin is an input pin, and the reason I know it's an input pin is because it's on the input line. And this one's an output because it's on the output line. And these are power pins because they're on the power line. And then I can draw the schematic around the inputs and the outputs and the power in a way that makes sense. So that's what we got going on there. So input comes in, DC blocking cap, base of the transistor, and then this is not connected right here because you don't see the junction dot. And then these resistors right here are creating a voltage divider, right? So you have plus V or V plus. You have ground, which is 0 volts. So you have the voltage of your supply, your positive DC supply, and you have 0 volts. And then you're going to have current that flows through these transistors. As the current flows through here, some voltage is going to drop across that transistor. You can calculate it using Ohm's law. Some voltage is going to drop across the potentiometer, and some voltage is going to drop across this resistor. So what the potentiometer does is when you turn the little screw up at the top, the wiper right here, this wiper, is going to move from touching this pin. It's going to move slowly up to touching this pin. So it wipes. It wipes basically across that resistor. And everywhere across that resistor, the wiper will see a different voltage because there's a voltage dropping across the entire potentiometer. So when it's at the bottom, it's getting the lowest voltage point, and when it's at the top, it's getting the highest voltage point. So anyways, so basically when you adjust the potentiometer, you're adjusting the DC voltage that's on the base of this transistor right here. And then, yeah, so. And then, of course, you've got a voltage drop here, which is your base emitter voltage. And then you have voltage drop across resistor and voltage drop across this resistor, which is in parallel with this capacitor. So in DC, you can ignore the capacitor because in DC, it's going to act like an open circuit as if it's not even there. And you can just look at the two resistors and say, okay, well, how's it going to bias? Where's it going to be? Okay, that's interesting. And then this guy up here, right, current is flowing through it, through the transistor to ground. So as the current flows through it, you'll have a voltage across it. And then as the current flowing through it changes, because the transistor is going to act like a linear switch or a valve, right? A linear valve. And a little bit in, it will cause a lot to go out. So a little bit and a lot. Well, where does that a lot come from? That a lot comes from up here. So a little bit goes in, a lot goes out. So a little goes in, a lot has to go in, so that a lot can go out. So a lot goes in. As that a lot flows, because a little flow here will make a lot flow here, this a lot flow is going to mimic what this guy does. And so the voltage drop across here is going to mimic the voltage signal. Well, the change in the voltage drop across this guy, R3, is going to mimic the change in the voltage here at the base. So, yeah, that's not a very good explanation, but you heard it from me at 9:30 on a Thursday night. But I'm taking tomorrow off, so I can stay up late and work on this. So, yeah, okay. So now that I've got that, let's jump over here. Let's show everything. All apply, okay. I'm going to delete this and this for now. Did I want to keep those? Yeah, keep them for now. Okay, that's not going to hurt anything. From soldering it up, the only thing I was thinking maybe I should do differently is I could use larger resistors, but I could do a different footprint on the capacitors. Like I could move this guy a little bit. So let's go down to 1 millimeter. Let's grab hey. Move to there. That's about right. Okay. Something like that. Need to change the size of all the reference designators. Size 1.5 millimeters. Change group. Whew. They're going to be a lot easier to read, aren't they? Yes, they are. Okay. I need to put P1 down here. Actually, I need to update my library to just have that in on the component. And then I need to make this guy. Let me escape. This just needs to be R. The next one, 6. 1, 2, 3, 4, 5, 6. We're gonna make that R6 because this is not IEEE 315. If it's P, it needs to be R. And then J. This is the more movable, so it needs to be P. So if I click on this guy, see how that P1, yeah, so there's P1, and we're going to put a dash. That dot stuff and the stuff. So that's P1, and then P1-1 is pin 1 on part reference designator P1, and pin 2 on P1, and pin 3 on P1, and pin 4 on P1, and pin 5 on P1. Okay, so this is P1-1, P1-2, P1-3, P1-4, and P1-5. Yeah, that'll be fine. And the part number thing down here, this library design is old. This library component is old, so okay. And this doesn't have the, so I need to update this library part. Yeah, okay. To go into the library. While I'm in there, I should change all the reference designators on those guys, so I don't have to fight with it anymore. Symbols. miniPCB, 5-pin, 33. Cancel. Footprint. This should have it, yeah. miniPCB, 5-pin, 33. All play, okay. Yes, this is fine. We just take this off. That stays. Part number, yeah, that'll have the revision in it. Yeah, and then we will set this to millimeters. 0.1. All, none. T-stop, apply, okay. Delete group, T-stop, delete group. all, apply, polygon, put it on the T-stop layer. There. Oof, maybe that was back one more. I think it was back one more. Okay, like that. Yeah. Like that. Okay, cool. Go back up to here. Grab this guy, drag it over one click. Like that. That's better. That's what I tell myself. But that's better. That's good. 0.5. Okay. These guys right here, they need to move 0.5 millimeter. So one click, one click. One click, one click. And then they need to shrink as well, if I remember correctly. 2. What was the standard? Oh, I need my ECO. Mini PCBs, engineering documents. We'll go into the Word document at this point. Oh, I probably had it open. I did have it open. Okay. Let's see, PCB 3305. So this is the standard, 2.4. All right, so that stays. And then just to double check that I successfully moved it to the correct spot, let's put this on a 2.5 millimeter grid. That's pretty close to right down the middle. Yeah, 2.5, 30.5. Yeah, 30.5, 2.5, 30.5. Ooh. 2.5, 2.5, 33. Man, isn't this nice, guys? This is just so nice. I'm telling you. The only thing I didn't do perfectly here is I didn't dimension P1, but I think it's centered on that one right there. Yeah, okay, cool. That's cool. Good job. Double check this one too. Is 30.5. Yeah, cancel. Okay, cool. And this part number up there, it's not in the spec. It just says it's on the opposite side as the logo. .5. Okay, I can drag it down one click just so it lines up with that. And then I should make it at least 1.5 if it's not. Yeah, let's make this 1.5 just because it's I could probably make it bigger too. Oh, I need to put it in the silk screen too. Yeah. 1.5. Yeah, that's fine. Okay, copy here, properties, B place. We'll just do B place. Apply. Cool. And then there. And then while I'm up here, I'm gonna grab this. Well, copy. Properties. P1. This is T place. That's good. That's good. Okay. This guy. should I put a white border around the edge, kind of for my keep out area? Yeah, I'm going to do that to myself. It's awkward, but, you know, T-place. Width, this is 0.4. Boom, that's good enough. Okay. Do I need to do all that, Nolan? Is it really gonna be better than if it didn't have it, or if it was just like harsh like that? Bam, 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 bam. Escape and delete like that. That was that. That's just weird. Yeah. Okay. There we go. Should I pull it down one more click? Oof, we just stole all that space. Oof, I'm going to feel it. I'm going to feel it. But we're going to do it. We're going to steal that extra 0.5 millimeter. Oof. Okay. Save, save. Go back to here. Library. Update all. Boom. All right, let's look at that. So this is on a 1 millimeter grid. I need half. 0.5. Give me the border here. Move this guy. Yeah. Bam. On the bottom as well. Bam. Cool. So that now when I do my ground plane, I'll just copy the white line that I drew, and then I'll know that it's always good. And then looking at this guy with the V-score, you really don't want to get much closer than what that is. I'm sure you could get closer, but we don't want to punish the board house. We want to make it as easy as possible to make this board so that they'll give us as competitive a price as possible. So we'll just stick with that. Now my pot is sitting on that outline. I'm going to leave it for right now. It's not extending beyond, so you don't really notice. My silk screen outlines are okay. They could be thicker, but like this guy is just slightly thicker. That's thicker than those, and it shows up a little nicer. But the thinner ones are okay, so I think I could leave that. Oof, man. And the logo updated and that, and so that's good. Okay. 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 I think this is good. We're not crowding P1 batch. I didn't set P1 to be 1.5, did I? Properties. There we go. All right, now we're now that's looking better. Okay, cool. These guys can go a little further. Sure, like that. Then rip up this way, and we're going to take it out. Okay. All right. I think we're on the verge of greatness, guys. I mean, this was acceptable. Like, if people would have, rushed to my door, I would have sold it hand over fist. But, you know, I think this is going to be a little nicer. It's the small things. It really is when it comes to board work. Just the little tweaks. Yeah. How bad does it look to have that come off the side instead of just send it up and over? Like, oh, not that bad, Nolan. Okay, well, if it doesn't look that bad, then this shouldn't be that bad either. Okay. Y'all can't hear it, thankfully, but it barks at me every time it's Eagle, it's the old Eagle. It barks at you. All right, it looks weird, but, we're just going to go with it. That'll be fine. It'll be fine. It'll be fine. Or drag that back down like that. And then I pull this guy off that side down there. This is not engineering, guys. This is just me being silly. Yeah. Well, at least he's honest about it. Yeah. Try and keep it real. It's fine. It's fine. It's fine. Okay. So if I take this back onto mill, put it down at 10, that's less than 10 mils. I know they say they can do not dimensions, options, assign, cancel. Oh. Whoa. Okay. Clear all. Yeah. What did he do? Did he just hit clear all? Oh my God. Thermal isolation. Yeah. It looks less than 10 mils. It really does. I don't know if I want to do that. Restricting distance. That one, I don't really know. Said 8, right? And just leave it at that. I'm not going to mess with that stuff tonight. I'm just going to leave it. So, yeah, that was that's a silk screen that goes onto the pad. That's just no one. Really? Yeah. Need to get into that footprint and edit that. Yeah. Okay. These guys have enough room. They could be now larger electrolytics. That'd be fine. Yeah, just tools, DRC, check. And it throws up the silk screen errors and then stuff with the logo. What was this? That's a error. Weird. Close. Okay, so I have an attribute on the part here, which is 5-A. This is X dash, just X dash, put X. I think it's just X. Rev. I'll just leave the rev there. But how do I just clear all those DRC errors? Just just clear all. Check and then clear all. Yeah, we do. That's how we roll. We're like, yeah, don't show me any of the errors. I don't mind wasting my money. I'll spin this as many times as I need. In fact, more than once, every time. Okay. So if I go back to millimeters, set this to 10, and move. I don't know, maybe inches was the way to go. Yeah, like if I with the panel image frame, yeah, I'll just cancel. But maybe I'll work up, I'm going to take this out. I'm going to take these out for now. I'm going to take them out now. We'll figure something else out. Okay, so I think that's good. We checked the holes. We extended the silk screen. We tweaked the tracing a little bit because we're OCD. None of this stuff changed. We left the resistors the same size instead of making them longer just because it's what fits. And we gave these guys a little bit more breathing room, increased the reference designator sizes. Are we going to leave the silk screen alone, or are we going to bump up the silk screen? I don't know. Where's my schematic? So clockwise should move away from pin 1. Away from pin 1 is higher. This is pin 1. Clockwise will pull the wiper that way. And that is correct. Well, it is, except I soldered the pot here on backwards. So clockwise, yeah, I should have put the pot on the other way. My bad. Okay. And let's see. That should be fine. Okay. So let's go grab us an ECO. So reminding us, this is what it will look like. This is the ECO which released the ECO base. Close this. And the way, here, let me run that script that exports this image. miniPCBs, that one. Export schematic image. Bam. Cool. All right, now we can go grab us an ECO. Ooh, this is the exciting part, guys. So this PC, Windows, repos, miniPCB, ECO, ECO base, ECO form. Guys, this is the very first one. Well, the very second one. So ECO title. This is a this is 04B-005. Yes. Initial release. ECO title. Yeah. -A. I'm just gonna that one. That's -A. Okay. DWG number 04B-005. DWG number. Yeah. DWG rev. A. Requested by N.Monteufel. Requested date today. Close the nav. Okay. Today. And description of change. Initial release. Statement of risk. No known risk. What? No known risk? I think you're just being lazy. Well, maybe I am. No, this is just work in progress. It's just work in progress. No known risk. That's fine. Justification of change. Product development. And then here we will, from file, miniPCBs, amplifiers, 04B, this one, that image, bam. Wow, it's small. Picture format doesn't let me do that. manually stretch it. Okay, it's good enough, right? Why did that not? Yes. Okay, delete. Wow. Okay. Escape, escape, escape. Let's say save. Wow, I really broke it, didn't I? Save. You know, sometimes don't save. Sometimes. Maybe I need to close this. Okay. All right, let's try this again. This is 04B-005-A. DWG number 04B-005A. And today. And initial release. No known risks. Risk. Product development. Schematic draft. Save. An ECO number is required. No, I thought it was automatic. I didn't make that automatic. 1001. Oh yeah, I didn't make it automatic. That's right. I have to manually do that thing. So save. Congratulations, saved successfully. Now it's got that log entry key, and now you can't touch the ECO number. That's locked. Everything else though you can still touch, including this guy, which corrupted my file just a second ago, which I did not appreciate. So miniPCBs, amplifiers, here. Oh, what was that? It's this one. What's in here? It's from a different date. Delete. And I do not know why. Put that back down there. Yeah. Bam. And then this guy. Drag it up. We'll drag it up. We'll drag it up to there. That's good enough. Okay. Save. Come down here. Save. Oh, super cool. Super cool. Okay. All right. Now we're going to say save and close. Come on. Don't let me down now. Okay. Now if I open ECO base, on this spreadsheet, we don't see that ECO yet. What? Well, but we've clicked the button. Well, come to the Overview tab, click Refresh. Number of ECOs went up to 2. When we come over to Orders, now see it. Wow. Wow. There it is. ECO 1001. Wow. Nice. Okay. So back in the schematic, here, we can come here, we can hit this, Rev A ECO 1001. There it is, 1001. And then the date is going to be for the ECO itself. We'll just go with that, right? Sounds decent. The ECO date. So Rev A date, or is it going to be the date of the release? Is it the date the ECO is finalized, or the date the ECO is requested? We'll make it the date it's approved, but that's the ECO number, so we can put that in right now. And yeah, save. Whoa, not that. Save. The reason why it put the image up there as opposed to where we wanted it is because this is the active project. We want this to be the active project. Yeah, okay. So now that that's the active project, we can come here and say export schematic, overwrite yes. And now that replaced the schematic in this folder right here. Well, they replaced the schematic in that one. So yeah, so ECO base, that's what that is. And save, sure. And then if we go into ECO records, we have 1001. And if we go into PDFs, you go to 1001, you see 3 PDFs. The first one is the first time we clicked the button. We clicked the save button, and the date timestamp on the PDF down here in the footer, right, like here, is the same as the log key and the date time right there. So this is a screenshot. So this is the record of the first button click, and this is the record of the second button click. Like that. This is the record of the third button click. Nice. And then let's, just for grins, we'll open the document, and we will see if we can easily replace the image. Is there a way to easily replace the image? I don't think so. So I have to hit backspace, then hit that again, browse for a file, go to miniPCBs, amplifiers, 04B, 04B, here. That's good enough. And now it has the ECO number. So now that we've got that, we could say save and close. Notice the log entry key doesn't change because that's what my code uses to find the record and update it. Now if we go into the latest, we scroll down, this has ECO 1001. So yeah. There it is. That's a big mess of text. People won't want to read, is it? But I think I want to put it there. Yeah, we'll leave it for now. We'll leave it. Mm-hmm. Okay, so now that we've got this, we can panelize it. So this is the layout, looks good, right? We're all happy with it. Well, the silk screen. If I'm going to modify the silk screen, I should do it on this way. So I'm going to modify the silk screen and then panel it, and I'm going to do that in another video because this one has gone on for a little while. 2 hours. So that's probably long enough. But yeah, we're probably half an hour away from having this thing ready to order. And we've been going pretty slow, so anyways. All right, well, I'm going to stop the video here and make another video maybe tonight. Maybe I'll grab an adult beverage from my little beer fridge and relax a little bit and then hit it again. So, okay. All right. Hey, thanks for, y'all are troopers. Thanks for hanging out with me. And enjoy your day or your evening or whatever you got going on. Anyways, later, guys. Thanks.